Now today I am going to prove these four. There was five. First one I already proved in earlier classes, earlier class or last class. Now I am going to prove these four theorem by Venn diagram first. Then I will prove these by analytical method and then by example methods in which the sets are given. Universal set is also given and you have to calculate this, prove this. Now, first part, intersection B union C is A intersection B union A intersection C. As I told you in my last class that, stated in my last class that since this theorem or problem contains three sets A, B, and C, first we have to draw the sets A, B, and C. In all the pictures, there will be three circles or three closed regions, each representing A, B, and C. So our first figure will be like this. This is A, this is B, and this is C. আমি কিভাবে বলেছিলাম A, B, C আঁকার সময় কি কি? Now this is S, the first figure F1 set A. So I will shade the portion within the A circle. Second picture will again contain three circles, that is three sets, and will shade the portion within set B, at F2. And third, A, B, and C. If you don't construct these three diagrams, you may lose your numbers. 1 marks will be deducted. Set C. Now to construct this, first I have to construct the B union C. Freehand drawing is enough. No scale, compass required. Only freehand diagrams are enough. Now B union C. As we know that B union C is this portion, the portion within C and B. Within C and B, entire C and entire B. This is B union F4 is equal to B union C. Now I will take intersection of this with this. To find the intersection, you observe which part are common to this. Now see this diagram. If we draw three circles like this, the total region within the S is divided into few parts. First part is the part 1, which is outside all the circles. Second part, which is in the first circle but not in other circles. Third part, fourth part, fifth part, sixth part, seventh part, and common part is 8. 8 permitted. So 8 different parts. Now from this diagram, comparing these two, you have to find which parts are common because you are taking intersection in both the diagrams. Now see, first part is not in any of the diagrams. Second part is in the part 2 is in this diagram but not in this diagram. Only see 6, 8, and 5th. 6, 8, and 5th. 6, 8, and 5th are common to these. So these two figure indicates that this is A, this is B, and if this is C, then A intersection B union C is nothing but this portion. A, B, and C. F5 is equal to A intersection B union C. So this diagram is constructed. Now to construct these two diagrams, I first have to construct A intersection B. then A intersection C, and then I have to take the union. To construct these two, A intersection B, A, B and C, A, B and C, I have to consult these two diagrams representing A and B. Now I have to find which parts are common to A and B. This portion is common to A and B. We can easily recognize it. F6 is equal to A intersection B. Next, F7, A, B and C. A, B, C, S is there, S is there. Now A intersection C. A intersection C is portion in this. Now I have to take common union. Union means the portions which lies at least one of the sets. So F7 is equal to A intersections. Now this is A, this is B, this is C. A, B, C, S. Now I have to take common of this, union of these two. So union means the portion which belongs to either of the sets. Now see, this portion belongs to this set but not in this, but still it will be in the union. This portion belongs to this portion is in the, that is the fifth portion is in this set but not in this, but still it will be in the union. And this portion, that is eighth portion, eighth part is common to both, so that will be in this. So this will be the union of these two diagrams. F8 is equal to A intersection B, union A intersection C. Now see, figure 8 and figure 5 are identical. Now see, figure 5 and figure 8 are identical. Then we have to write figure 5 as I expressed in for the previous sum on a previous class. Likewise, we will say that since if figure F5 and figure 8 are identical, so these two sets, the sets represented by the figure F5 and F8 are equal. That is, this is equal to this. So proof by Venn diagram is done. Clear? Now I am pausing the video. Next, I am going to prove this theorem. Now see, this theorem contains only two sets A and B. So within the universal set, I have to draw two circles. In this sum was consists of three circles. So we have drawn three circles. We have to draw three circles. In this case, two circles. So first figure is A and B. First I have to say 8 for 1 is equal to set A. So I set the set A, position inside A. Second figure will show set B, A, B, A, B. F2 is equal to set B. Now I am going to construct this. To construct this, first I have to do the work within the bracket. That is A union B. First I have to take A union. Now likewise this, if we draw two circles within S, the regions, the total region divided into four parts. 1, 2, 3 and 4. One part is outside all the circles. That second part is on the first circle A but not in B. The fourth circle represents region within B but not outside A, and third portion represents common to all. Now we have to take union of these two. S, that is A union B. Union B means any portion within any one of the sets will be considered. Now see, first part 1 is not included A or B any set. So this outside portion will not be there. Then the portion 2 is there. So 2 will be there in my union. 4 is not in this diagram, but in this diagram. So 4 will be this there. 3 is in this diagram and in this diagram both. So 3 will be this. So union will look like this. So F3 represents A union B. Now I have to take its complement. Complement means I have to set the portion outside this set. Outside this set. I have to set the portion outside this set. S. F4. A union B complement. So this was A. This is A, this is B. This is A union B. I am taking complement of A union B. So I have to set the portion outside the A union B. So that is this portion. This set represents A union B complement. So left hand side set is constructed, diagram of this. Now I have to construct this set. To construct the diagram of this set, first I have to construct the diagram of A inverse. A inverse means this is set of set A. So A inverse means outside the set A. The portion outside the set A. So that this is A, this is B, A, B. A complement means outside portion of set A. Sorry. Portion outside set A. This is A complement, F5. A complement. Next, I have to construct B complement. B. This is A, this is B. So B complement means outside the B. So I draw B complement. Only hand drawing is enough. No scale, compass needed. B. Now I have to take intersection of these two. Intersection means portion, that is 1, 2, 3, 4. Which one of these 1, 2, 3, 4? Now see, I have to take intersection, that is the portion 1, 2, 3 or 4 which lies in both the diagrams. Now see, the portion 1 is in this diagram and this diagram also. So the portion 1 will be in my F6 is equal to B complement, F7 is equal to A complement intersection, B complement. Now I draw A and B, A and B. Now see, the external portion lies in both the graphs, both the diagram, external portion. So external portion will be shaded. Now see, portion marks 2, marks 2. 2 is not in this set, this diagram, but in this. But since we are taking intersection, the portion to be shaded must be in both the diagrams. So second 2 will not be considered. Second portion. The third portion is not in this, not none of the diagrams. So third portion we won't consider. Fourth portion included in this diagram, but not in this. So to be in intersection, it should be in both the diagrams. So this portion also will not be shaded. So only portion will be shaded is outside of both the circles. Outside portion of both the circles will be to be shaded. Bas Now you see that these two diagrams are identical. Now see that these two diagrams are identical. And this establishes that the sets are equal. Okay. Now I will prove that A intersection B complement is equal to A complement union B complement for any two sets by Venn diagram. So first diagram, I don't have to explain anymore. S A B A B. You know what to write. Second diagram is A set B. You know what to write. You know what to write. Next comes A intersection B. This is A, this is B. So A intersection B is common part of A and F3. A intersection. Now I have to take in complement of A intersection B, that is portion except A intersection B are to be shaded. This is S A B. So portion outside A B intersection to be shaded. A B intersection to be shaded. Now A and B are there, A and B. So it is F4 is equal to A complement, A intersection B, that complement. Next I have to construct this set. To construct this set, I have to draw A complement and B complement first. F5 is equal to A complement. A complement is portion outside the set A. This is A complement. As we done earlier, this will be our B complement. A, B, S. So portion outside B will be shaded. Portion outside B, only the portion outside B will be shaded. B complement. F6 is equal to B complement. Now I have to take their union. A, B, A, B, S. Now as earlier we noticed that there are three parts, 1, 2, 3 and 4. Now observe which parts are both in both the diagrams. Now see one part that is outside the circle. The portion outside both the circles are included in both the diagrams. So this portion must be considered. Since you are taking union, so any portion in either of the sets will be considered. Now see the portion 2, not included in this diagram but included in this diagram. So 2 will be included here. Now the portion 3 not included here, so 3 will not be included. Now the portion 4, fourth portion is included in this diagram but not in this. So it will be in the union. So except these, all other portions to be shaded. So I shed all the portions except these. Now you learn how to identify the portions to be shaded. First, at that You are as you are beginner in set theory, first follow this method of identifying the portions. I have to, or you have to shed, and after a few days, a few practice, it will be it will look very easy to you. It will look very easy to you. Now F7 is this. Now F7 is equal to A complement union B complement. Now see F7 and F4 are identical, and this establishes the theorem. Venn diagram. This establishes the theorem. Okay. Next, we are going to prove this theorem, this relation. Then this sum contains two sets A and B, so I have to draw the two sets A and B first. Next, to construct the left-hand side set, I have to construct A minus B and B minus A. Then I have to take their union. Now I am finding A minus B. This is S, A, B. So A minus B is this portion of A, which is not in B. F3 is equal to A minus. Then B minus AB, the portion within B but not in A. F4 is equal to B minus. Now I have to take their union. Union of these two sets. This is S, A, B. Again see if these are the portions 1, 2, 3, 4. Union means any portion within this must within at least one of the sets will be considered. Now see the first portion 1 outside the circle is not included in both either of the sets. So this portion will not be in our choice. The second portion 2 is in this set but not in this. So this portion I have to shed because we are taking union. Now the third portion is not in this set and this set, not in either of the sets. So this portion will not be considered. And likewise, fourth portion is included in this set, not in this. So fourth portion to be shed. So I will shed only these two portions. So let me shed the portion. Yeah, so beautiful. What a drawing scheme I have. A minus union B minus. This is F5. Clear? Construct this. Construct A union B. Indranil, mute kar. Presently disturbing sounds are. Now first I have to construct A union B. A union B already you have know. That's A union B is this portion. No further explanation needed. A union B. This is F6. Next, A intersection. A intersection. A intersection be this portion. Now I have to construct this. That is, I have to now I have to subtract this portion from this. So the diagram will look like this. Now see, this is F8 is equal to A union B minus A intersection. Now see, these two diagrams are identical. Now see, these two diagrams are identical and it establishes the theorem. This proves that both the sets are equal. Recording start. Now see, NA represents number of elements in set A. Now question is, what is N of A union B? What is N of A union? Now see, this is A, this is B. So A and B. So this is NA. NA means number of elements in A are counted. NA plus NB. Number of elements in B are counted. Now see, number of elements within this portion are counted twice. In this addition, these elements in this portion are counted 2 times. So this is not equal to N of A union. It is more than N of A union. How much? It exceeds A union B? This much. The number of elements in this portion is the difference between these two. So what we have to do to make these two equal? To make these two equal, we have to subtract the number of elements in this portion. And we know that this portion is nothing but intersection of A and B. This portion is nothing but intersection of A and B. So N of A union B is NA plus NB minus NA intersection B. Now see, we have to calculate N of A union B union C. And proceeding in this way, we can calculate A union B union C union B and so on. But only up to 3 is needed for our exam purpose. So N of A union B union C. We write NA. The NA means 1 plus 2 plus 7 plus 6. NA. NA is 1, 2, 7, 6. All are in A. So 1, 2, 7, 6 are counted. Plus NB. NB means 2, 7, 4 and 3 are counted. 2 again counted. So 2 is counted here. 2 is counted here also. 7 is counted here. 7 is counted in B also. So this is B. NC. Now see, C is 6 plus 7 plus 4 plus 5. C portion. C portion. Now if you see that the 2 is counted twice. 6 is counted, 4 is counted twice. 6 is counted twice. And 7 counted thrice. 7 counted 3 times. So this is not the sum of this. Unless otherwise, all these are null sets. If 2, 7, 6, 4 are null set, then only this is equal to this. Then only this is equal to this. Because all are counted. We can write it 1 plus 3 plus 5 plus 2 into 2 plus 6 plus 4. 2, 6, 4 are counted 2 times. Plus 7 into 7. So 7th portion is counted 3 times. So now see, but our sum will be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. A union B union C is nothing but this. But when we added this, it becomes like this. So 1, 2, 3, no problem. They come single time. So 2, 4 and 6 arrived. 1, 3 and 5. 1, 3 and 5 arrive one time each. So no problem. But 2, 4 and 6 arrive 2 times. So I have to subtract them 1 times each. How did we do this? We in A intersection. A intersection B. So this portion is subtracted. So minus 2 minus 7. 2 and 7 are subtracted. So minus 2 minus 7. 2 times and 1 time subtracted. Now the sum contains 1 time 2 and 2 times 7. 7 was taken 3 times. So it is now 2 times. Minus n of A intersection C. C A intersection C. So 6 and 7 are subtracted. Minus 6 minus 7. So this is minus 6 minus 7. So 6 was taken 2 times and 1 time subtracted. So now this sum contains 1 times 6. 7 was taken 3 times and 2 times subtracted. So 7 is also 1 time. So only 4 is 2 times here. So I have to subtract 1 time 4. This 4 1 time. What I did? N of B intersection C. Now see, when B intersection C contains 7 and 4. Minus 7 minus 4. Now see, 7 is taken 3 times and subtracted 3 times. So this sum contains 0 times 7, 1 time 4, 1 time 2, 1 time 6, 1 time 1, 1 time 3, 1 time 5. Only 7 is not there. So we have to add 7. 7 is A intersection B intersection C. Because 7 is in intersection of all the 6. That's why plus 7. Now see, these two sums are equal. So both sides are balanced. So we get the formula as this. So n of A union B union C is equals NA plus NB plus NC minus n of A intersection B minus n of A intersection C minus n of B intersection C. Sija mute karo. And then add n of A intersection B intersection C. Now see, to calculate the number of elements of any set or combination of sets, the role of Venn diagram is very important. The Venn diagram tells us what to do, what to add, what to subtract, and this. So you should follow the Venn diagram when you need to calculate the number of elements of any of these sets. For example, let n of A minus B union B minus C. We are going to calculate n of this A minus B, B minus C. We know that A minus B is this portion and B minus A is this portion. So this shows that NA, this portion has NA minus this. That is n of A intersection B. So this portion calculated plus this portion has NB minus n of A intersection B, because this is an intersection portion. So now if we draw these two, add these two, you will have the number of elements in this set. After simplifying, you will have n of A union B minus n of A intersection B. Why? We have just established that n of A union B is NA plus NB minus n of A intersection B. So this is NA plus NB minus NA intersection B. So these 3 gives you n of A union B. And this left behind. So this was in this way, on the guidance of the Venn diagram, we calculate the number of elements of any combination of sets. Okay. Recording the on recording. Now Recording on, आगे recording है. Before we start, we should remember the following. Number one, here we will use two very important words, which are and or. Two words and or. For example, x belongs to A and B. That means x is an element of both the sets. Both the sets. Mention the, remember the word. Both the sets A and B. X belongs to A or B. That means X is an element of either of A or B or both. X belongs to A or B means X belongs to A, X belongs to B, or X belongs to both of A and B. So it is in inclusive sense. Second is and is distributive over or, and or is distributive over n. And is this, what is distributive property? That you have learned in class 7. Whether you remember or not, example, see the example. 5 into 3 plus 4. It was 5 into 3 plus 5 into 4. But 5 plus 3 into 4 not is equal to 5 plus 3 into 5 plus 4. These examples you learned in class 7. And in that class, it was told that multiplication is distributive over addition, but addition is not distributive over multiplication. Likewise, division 5 divided by 3 plus 4 is not equal to 5 divided by 3 plus 5 divided by 4. But see, 3 plus 4 is divided by 5 is equal to 3 divided by 5 plus 4 divided by 5. So when division is on the right of positive, then it is not distributive. So when when division is left at the left of addition, then it is not distributive. But when division is on the right of addition, then it is distributive. That's why it is called that division is right distributive over addition. That we have taught in class 7, 8, like this. So that you can remember. So like this is distributive. What is, see the example, x belongs to A, look at that, there is and. So and replaces into here. And x belongs to or. So you can replace or by plus. So A and to B plus C. Now see, A is distributed over R, and B and C or comes in between that. This is called proper distributive property. Similarly, or is also distributive over addition. If you find or, then some bracket, you can distribute or on the elements within the bracket. These two are very important properties we will use in analytical method of proving set theoretic problems. Now say number 3. X belongs to A intersection B as per definition. That means X belongs to A and X belongs to B. But X belongs to A union B means X belongs to A or X belongs to B. Not and. It is or. Union means or, intersection means and. Now see, X does not belong to a complement. X does not belong to a complement. If we go through the diagram, this is A, this is A. X does not belong to X. So X is not in there. So X is there. So X is not outside the A. X is not in outside A. So X lies inside. You are not outside your house. That means you are inside your house because you are blocked down. and X does not belong to C. Now see, very important result. 5 is very important result. Now see, there is N. There is N. Two relations are there. Two relations. Now see, and there is a relation which almost look like this. Almost look like this. These two relations. What is the difference? In this relation, it was belongs. It was belongs. When it is belongs to an and in between, belongs to an and between, that will be intersection. Belongs to an intersection. Belongs to an intersection. But if it is not belongs to, and in between, then it will be not belongs to and union there. In case of belongs to, it will be intersection if and is behind, in between. But if it is not belongs to and in between, that will be union. Just opposite. Intersection, a complement, and not belongs to, in case of not belongs to. Similarly, look that there is X belongs to A or X belongs to B. It was X belongs to, and since it was or, it was union. So if I convert this to not belongs to, so it will be not belongs to, and it will be, instead of union, it will be intersection. That I have written this. So these 6 things you have to learn very, very minorly fast. And now see how we apply these properties on solving or proving different set theory problems or theory. These 6 things we have to remember. These 6 things we have to remember. Mainly we use 3, 4, 5, and 6. Mainly we use 3, 4, 5, and 6. So I will copy these on the board, and then I will discuss some problems on the board. Now we are going to prove some set theorems of set. And to solve these theorems, we will need these 7 things. First, X belongs to A union B implies X belongs to A or X belongs to B. X belongs to A intersection B means X belongs to A and X belongs to B. Next, see, there is and means intersection, or means union. But if the relations are instead of belongs to, we use does not belongs to. In case of X does not belongs to A and does not belongs to B, does not belongs to, implies X does not belongs to. Now see, and implies intersection, but when it is does not belongs to, and implies union. Likewise, X does not belongs to A, or is there, X does not belongs to B. In case of or, it was union, but here it is intersection. Next, see, A equal to B, equality of two sets defines that it is if A is subset of B and B is subset of. To prove that two sets A and B equal, we have to show that A is subset of B and B is subset of A. How we prove that? We'll take an arbitrary element from A, any element that represents all elements of A, and by logic, we'll establish that that is an element of B. We'll consider any element, an element from A, and by mathematical process, we'll establish that that element in B. And that will prove that all elements of A are elements of B. That is the definition of set. So that proves that A is subset of B. Again, we have to consider an element from B, and applying mathematical process and processing will prove that that element is also an element of A. And that will establish that all elements of B are elements of A. Hence, B is a subset of A. As soon as we establish that A is subset of B and B is subset of A, by equality of sets, by definition of equality of sets, this is definition of equality of sets, we can conclude that, we can claim that the sets are equal. To solve this, we need two more important results. OR is distributive over and is distributive over OR. So I am going to prove this applying these formulas. So first I have to prove this is a subset of this. To prove that, I will consider an element from this element, this set, and by logic, by mathematical process, I will prove that this is an element of this set also. Since it is an element of this, it is an element of this. That will establish that this is subset of this. Now I do this. Let X belongs to A intersection B union C. Let X be an element of C. Now I am going to show that the X is an element of this also. And since I have considered X as any element, I did not choose any particular value. X represents all the elements of this set. So if X belongs to this will establish that all elements of this set are elements of this. Now since it is AND, so X belongs to, that implies A, AND means AND. A intersection implies AND. Now I use AND. X belongs to B union C. That implies X belongs to A and now say X belongs to B union C. Union lies in union implies this or this. So within bracket X belongs to B or X belongs to C. Now say AND is outside or is inside. So I'll use distributive properties. So that implies X belongs to A and X belongs to B or will come out. X belongs to A and X belongs to C. Now you see that there is AND. X belongs to A and X belongs to B. And means X belongs to A intersection. X belongs to A intersection. Or X belongs to A intersection C. Now see these two are two sets. X belongs to both the sets or is in between or means in union. That implies X belongs to A intersection B or represents union. X belongs to this union A intersection C. Now see I have considered an element from this set and I established that this element is also an element of this set. So that establishes the set A intersection B union C is a subset of A intersection B union A intersection C. Next, I will establish that this is a subset of this. Let X belongs to A intersection B union. We will take this as Y union A intersection B. So here operation is union. Union means OR. So that implies, Y belongs to A intersection B or X belongs to A intersection B. A intersection C. A intersection C. Now see intersection means AND. So Y belongs to A and Y belongs to B. It will be within bracket because I am deriving this from this, or X belongs to A or N. Intersection means N. X belongs to C. Now you see that OR and as distributive property. So Y belongs to A. That implies Y belongs to A and will come out of the bracket and OR will included Y belongs to B or Y belongs to C. Now to apply distributive property, you will have this expression. That implies Y belongs to A and since it is OR, Or means in union. Y belongs to B union C. Now see Y belongs to A and Y belongs to B union C. Since it lies in both A and B union C, it lies A intersection B union C. And that is established that I have considered Y from this set, and then I just proved that Y is also in this set. That establishes that all elements of this set are elements of this set also. That shows that A intersection B, A intersection B union A intersection C is a subset of A intersection B union C. This is true, and previously I proved that this is subset of this. So 1 and 2 implies A intersection B union C is equal to A intersection B union A intersection C. Proved. Sorry, all will be Y. Huh? Read as Y. Instead of X. Huh?